In this quick video, I'm going to show you how to do calculations pertaining to percent composition. This is found in your printed notes, so I'd get those out, page 18 and 19. A little later in the video, you'll be working through some questions that are in your notes, so you can fill that in as you go. So let's get started. First of all, there's an important law in chemistry known as the law of definite proportions, and this states that a chemical compound is always the same in terms of its proportion of elements by mass. So basically what that means is no matter what the compound is, no matter where you find it, be it here in Canada or in Australia or on Moon or the Mars or in Mars for that matter, if the percent composition of hydrogen and oxygen is 11 and 89 respectively, it is water. And if it's not those percentages by mass, then it's not water. Here's a simple analogy based on your fruit consumption. So if, for example, you eat bananas and blueberries in a given day, well, we're going to look at eating 2 bananas with a mass of 65 grams and 25 blueberries each with a mass of 4 grams. Now, if you did the percent of types of fruit, it would clearly be heavily weighted towards blueberries. You ate 25 blueberries versus only 2 bananas. But if we look at the masses, it's a different story. And so you should all know how to calculate a mass, or sorry, a percent. So there's the mass of bananas times 100 is going to give us our percent bananas. So 2 times 65 divided by the total mass of fruit equals 56.5% bananas. And we've only eaten 43.5% by mass of blueberries. So again, percent, as you are aware, is basically a ratio. And when it's percent by mass, it's the ratio of masses. So this question is in your printed notes, so you might want to pause your video and get this question out. What we're looking at here is given carbon dioxide. So we know the formula for carbon dioxide, it's CO2. So what we're going to need here, if we have 1 mole of carbon dioxide, is the molar mass of carbon, oxygen, and carbon dioxide. And so there they are. And now we just calculate a percent carbon. So the percent carbon is going to be the molar mass of carbon divided by the molar mass of carbon dioxide times 100. So we have 27.29% carbon. The percent oxygen then is going to be 100 minus 27.29%, or 72%. Alternatively, you could calculate it this way, which is simply by doing the same thing we do with carbon. But remember, it's 2 times oxygen because there are 2 oxygen atoms in carbon dioxide. And when we do it that way, we get the same answer, 72.71%, which we should get. Now, this one is in your textbook, and once again, we have a compound, sucrose, C12H22O11. So, what's the percent composition? Well, we need the molar mass of sucrose, so there it is. Now, I haven't used the unit. We can use the relative mass. And so percents of carbon and hydrogen are both shown there, and then percent oxygen, once again, as a final percentage calculation. Now, one more example. At your desks, and this is in your notes at desk, name and calculate percent nitrogen in each of the following. So in this case, it tells us to only look for percent nitrogen. If it doesn't say percent of a specific atom in a compound, you calculate percent of everything. But obviously, in this case, we only are interested in the nitrogen. So first of all, N2O5 is called dinitrogen pentoxide. It's a molecular compound, so we have to use the prefix system. And then we want the percent nitrogen. Well, the molar mass of nitrogen is 14.01, and the molar mass of dinitrogen pentoxide is 108.02. And so we can quite quickly calculate the percent nitrogen in this compound. So here's a little bit of an extension question. So you happen along the road and you find a pail of gold 3-phosphate. So what's the value of gold in this compound based on today's gold prices? Well, we have a mass of a compound, but we're only interested in the gold. The phosphate in gold 3-phosphate is insignificantly valuable relative to the gold. So we have to find a percent gold first. But it's just gold is what we're interested in. So again, molar mass of gold 3 phosphate, and then the percent gold, to find the percent gold. Now I haven't multiplied by 100 here because we're going to use this fraction to determine a value of gold. So we could convert it to a percent if we wanted. It would just be 41.72%. But when we use that percent, we have to express it back as this fraction. Or one thing you want to know, measurements of heavy metals in terms of mass are typically done now in something known as the troy ounce, or for a symbol OZT. And so it's an imperial measure, but it's still commonly used, and it's still the mass reported on as a gold standard. So here's some conversions. So 1 troy ounce is defined as equal to 31.10 grams. So there it is in ounces. So it's not the same as an ounce. So we're going to use those conversions as we proceed. So first of all, it makes sense to me to determine the mass in grams because we're given a mass in kilograms. So 1.5 kilograms, convert it to grams, multiply it by our fraction or our percent gold, and we get 604.89 grams. And so gold prices are commonly reported in dollars per gram, and that was as of this morning. So there's our mass multiplied by the dollars per gram, and we get 22,000, a little more than $22,000. Well, if we want to do it in using the troy ounce, which is the more common way to actually report the value of gold, we first have to convert grams to troy ounces. And so there's the conversion. 1 ounce troy equals 31.1035 grams. So we use that conversion factor, and we get, and then we multiply by your same fraction, and we get 19.45 ounces troy. So there's the percent gold in our gold 3 phosphate. And we simply multiply that then by the price per ounce, troy ounce, which is $22,131.5. So it is pretty much the same value. Within $5, that's not too bad for using 2 different conversion methods. So that's percent composition.